Dear lovely viewers, thanks for tuning in. We have another interesting problem, so let's go look at it. We have a nice logarithmic equation here from this table of Ivy League University's entrance exam problem. S raised to the power of log to base 3 of the argument x equal to 81s cubed. If you look at the exponent here, we have log to base 3, and 81 can be expressed as a power of 3, which is 3 to the 4th. And we have s cubed here. So the best approach to solving this problem is to take the logarithm to the base of 3 on both sides. So on the left side, we are going to be having log to base 3 of this entire expression here, s to the power of log to base 3 of the argument x. We do same to the right side. So we have log to base 3 of the argument 81s cubed. Put this in parentheses. Then from the laws of logarithm, I'll consider the power rule and the product rule. If I have log to the base of a of the argument b raised to the power of n, I can write this as m multiply log to the base of a of the argument b. So this is the power rule of logarithm. Also from the product rule, if I have log to the base of a of the argument b multiply c, I can actually split this. That becomes log to the base of a of the argument b plus log to the base of a of the argument c. Hence, I call this rule the product / the addition rule. If you start with product, you end with addition. If you start with addition, you end with product. So with these intricate laws of logarithm, I shall now refine the context of this problem. As you can see here, the argument of the log to base 3 we have here, which is this x, is raised to log to base 3 of the argument x. So we are not going to be having log to base 3 of the argument x multiply log to base 3 of the argument x. Then on the right side, if I use this product / addition rule, we shall be having log to base 3 of the argument 81 plus log to base 3 of the argument s cubed. Okay, with this, can now go ahead to simplify. Now log to base 3 of the argument x multiply log to base 3 of the argument x. That's log to base 3 of the argument x whole squared. Then we have 81, which is 3 to the 4th. We shall have log to base 3 of the argument 3 to the 4th plus log to base 3 of the argument s cubed. On the right hand side, we shall engage the power rule again. So we are going to be having 4 log to base 3 of the argument 3 plus this 3 will multiply log to base 3 of the argument s. Now, there's also a rule in logarithm that says that log of the base of the same argument is 1. So log to base 3 of the argument 3 is 1. So I can write this right side as 4 plus 3 log to base 3 of the argument x. Then I shall combine both the right side and the left side of the equations together. So we have on the left side log to base 3 of the argument x whole squared equal to, on the right side we have 4 plus 3 multiply log to base 3 of the argument x. Now we shall make a substitution. Say let p equal to log to base 3 of the argument x. Now log to base 3 of the argument x whole squared becomes p squared. On the right side we have 4, then 3 log to base 3 of the argument x, that becomes 3p. So this is a quadratic equation. I shall rearrange it in the standard form. That becomes p squared minus 3p minus 4 equal to 0. So this quadratics is very easy to factor. So we shall consider positive 1 and negative 1. No, positive 1 and negative 4. So we have p plus 1, p minus 4 equal to 0. So you can see that if we add 1 and negative 4, it will give us negative 3. If we multiply 1 and negative 4, it will give us negative 4. So we are going to have p plus 1 equal to 0 or p minus 4 equal to 0 from the zero product property. So if 1 goes this way, it becomes a negative. Negative 4 goes this way, it becomes a positive. So we have our two values for p. Then we shall also find the corresponding values for x. So I will recall that p equal to log to base 3 of the argument x. So for our first case, when p is equal to negative 1, so when p is equal to negative 1, we are going to be having log to base 3 of the argument x equal to negative 1. Now this a logarithmic equation. We can transform it into its exponential version. So s becomes 3 to the power of negative 1, which is something as 1 upon 3. So this is the first value for x. So when p is equal to 4, we are going to be having log to base 3 of the argument x equal to 4. If we do same by transforming into its exponential version, s will be 3 to the 4th. If you multiply 3 by itself 4 times, we have 81. So guys, we have our two values for x, s equal to 1 upon 3 and s equal to 81. Then we shall test for extraneous solutions, whether these two values of x actually satisfy our original equation. I will record the original equation. S to the power of log to base 3 of the argument x equal to 81 s cubed. So if s is 1 over 3, we are going to be having 1 upon 3 raised to the power of log to base 3 of the argument 1 upon 3 equal to 81 multiply 1 upon 3, then cubed. So we are going to have. Now, 1 upon 3, using the inverse law of exponent, that's 3 to the negative 1. So we'll quickly take care of that. So 3 to the negative 1 raised to log to the base of 3 of 3 to the negative 1. This is interesting. On the right side, we have 81 multiply 1 upon 27. So if you watch what we have here, if this negative 1 multiplies this negative 1, we are going to be having a positive 1. So the left side is 3 log to base 3 of the argument 3 is equal to the right side. 81 multiply 1 upon 27. 27 divided into 81, that's 3. And look, guys, log to base 3 of the argument 3 is actually 1. So we have 3 to the power of 1 equal to 3, which is something as 3 equal to 3. So in this case, the left-hand side is equal to the right-hand side. So s equal to 1 upon 3 is a valid solution. For the other guy, s equal to 81, we shall do same. We are going to be having s, okay, no need to write the expression again. The equation is here already. 81 raised to the power of log to the base of 3 of the argument 81 equal to 81 multiply it, okay, 81 to the power of will be 81 multiply 81 to the power of 3. So here, I can easily use the base of 81 to clarify this. Same thing as 81 to the power of 4. Then on the left side, I shall break it down into base 3. So I'll be having 3 to the 4th log to base 3 of the argument 3 to the 4th. Okay. So If I use the power rule for the exponent, I'll be having 3 to the fourth, 4 log to base 3 of the argument 3. Will it be equal to 81 to the power of 4? Okay, here we have 4 multiplied 4, which is 16. That will be 3 to the power of 16 log to the base of 3 of the argument 3. I want to break this one to base 3. This will be 3 to the power of 4 or to the fourth. Okay? Now you can see that log to base 3 of the argument 3 is 1. On the left side, we have 3 to the power of 16. Now on the right side, from the power rule of exponents, 4 times 4 is 16. We also have 3 to the power of 16. So the LHS is equal to the RHS. So it means that our second solution is also valid. So guys, we are done with the class. Please, if you like this video, make sure you share with your friends and colleagues, and also subscribe and follow for more. See you and stay blessed.